Alright, here we are with the Practice Quest key. I have not been through this too much, so I'm doing this live for the first time. Here we go. We are finding the integral from 0 to 10. So that's bounded from 0 up to 10 of this function f of x, given with this nice curvy line here. It just barely passes the vertical line test, but it does work. We're using 5 rectangles, so we're going to divide that into fifths, so that's every 2 units, and then we're going to use left-hand endpoints. So the first rectangle has a left-hand endpoint right there, and it goes that wide. Then the next one has a left-hand endpoint right there, and it goes that wide. The next one has a left-hand endpoint right there, and it's as wide as that, and so on till we have our 5 rectangles. And we just need to figure out how tall each one is. And this one right here is that wide. Okay, so just draw this clearly, and you'll see that you can shade in, I guess, for clarity if you want to. So that is what we've got for an area. Well, I'm calling this one 3 high. That looks like that's 4 high. This is maybe 5.5 and 6.5 and then 7. And we're just going to add up all of these and multiply by how wide they are. And these both, all of them are 2 units wide. So that's 3 and 7 make 10, 6.5 and 5.5 make 12. That's 22 plus 4 is 26. So this is going to be 26 times 2 equals 52 units. All right? So that's all you need to do. I'll break that down and show you more clearly. Please sort of show how each of those rectangles adds up, but I won't do it on the video here. Find the integral based on the graph of a half circle. You're being told this is a half circle. If you were not told that, it would be harder. Using common geometric formulas and your understanding of what this is. Well, this is telling us to integrate from 4 to 8, so that's from right there to right there. So really, we're trying to find the area under the curve. That's all that notation is telling us. That's a quarter of a circle with a radius of 4. So this is going to be equal to 1/4 pi r squared, which equals 1/4 pi times, in this case, 4 squared. So that's going to be 16. 1/4 of 16 is exactly equal to 4 pi. Okay, so that's just a pretty straightforward question. Don't make it any harder than it is. 3. Find the area under the curve defined by the x-axis and this function right here. And using 6 rectangles, well, from 1 to 4, if we call that 1, 2, 3, 4, that's our range right there, or our domain actually. I have graphed it on the calculator. Okay, so that's what that looks like. It's nice if you have the trace feature. You can just type in your x values. So if I type in 1, I see that it is in fact 0. If I type in 2, I see that it's 1. If I type in 3, I see that it's 4. And I can get the values here for my graph quite simply. So if I make that 1, 2, 3, and 4 high, when I'm at 3, I'm up to 4, and when I go to 4, I'm all the way up to 9. Whoops, that was silly. So I'm going to make this half that scale then. I'm going to make this be 1, 2, 3, 4. There's 5, and 6, 7, 8, 9. There's 10. Okay, so that was foolish of me to start graphing. So there's 4. And then when I go out to 4, I'm up to 9. So here are my points. And 2 was 1, and 1 was 0. So my graph is a curve, a parabola that's going up like that. And I'm going to make these slices. We want 6 rectangles. So this is halfway in between like this, each one of these. Alright? So I'm going to total up, and this is using right-hand endpoints. Okay? So I'm going to need a data point here, or a height. This is going to be the boundary of my first rectangle. So that's 1.5 comma, how high is it? Well, again, I can go back to the calculator, type in 1.5, and it's got a height of 0.25. That's comma 0.25. Okay, so I will find all of these heights for my right-hand endpoints, and then my rectangles will look like this. Okay, and so as I write this list, the first one is going to be, let's see, 1.5, and then 2, and then 2.5, and then 3, and 3.5, and then 4 for my right-hand endpoints. So again, if that's 0.25 is my height on all these, 2 is a height of 1, then 2.5, haven't done that yet, is a height of 2.25. 3, I think we found out, was a height of 4. Whoops, that's 4. 3.5, haven't done that. And that's 6.25. And then 4 is 9. So again, these are the heights of the rectangles. I'm going to add up all of the heights. That's 2.5 when I combine those, 3.5, 7.5, 13.75 plus 9 is 22.75. But remember, each one of these rectangles is half a unit. Okay, you can find your delta x with that little formula where you just do 4 minus 1 divided by how many rectangles, your n number, that's 6. So that's 3 divided by 6 equals 1/2. So I'm going to take this all and multiply it by 1/2, and I will get my answer. So 22.75 divided by 2 is 11.375. 11.375. Okay? So I didn't think to ask you to solve this theoretically, but maybe you want to do that for practice, because I think that's a good way to do it using Riemann sums, which is these little rectangles, or to use integral techniques. All right. So here we've got find the second derivative of f of x. It's like we did in class today. We're going to break this into 2, and then we've got x to the third over x to the 1/2 minus 20 x to the minus 1/2, and I will then simplify this one, so it's 2, and then 3 minus 1/2 is x to the 5/2 minus 20 x to the minus 1/2. And now I just find my first antiderivative, so I'll label it f prime of x. I'm going to add 1, so that's x to the 7/2, and when I multiply that out front, it's going to need to be 2. So if you get stuck, you can just write a little equation. I know that 5/2 times some mystery number a, the coefficient, is going to give me